Hello everyone, today we are going to go through diagonal difference, which is a problem under warm-up algorithm of HackerRank. So without wasting time, let us have a look on the problem statement. So here's the problem statement. Given a square matrix, calculate the absolute difference between the sum of its diagonals. So the problem statement is very short, but in the problem statement, we have some words we really need to understand in order to go forward, which are square matrix. What is a square matrix? What is a matrix? What is a square matrix? What is a diagonal matrix? And from there, if you are able to figure out what those elements are referring to, we'll be able to have the sum. So let us read further. Maybe we are going to understand more about what we are supposed to do. For example, the square matrix R is shown below here. So why is this a square matrix? Because the number of rows is equal to the number of columns. So we have 3 rows and 3 columns. This is what makes this matrix to be a square matrix. And the left to right diagonal is 1 plus 5 plus 9. Where are they taking those values? The values are taken from year to year. So if you are moving from the left to the right and we are taking the value we are going to meet on our diagonal, it will be 1, 5, and 9. And from this, we know that we took all the elements in the diagonal from left to right, and for the second diagonal will be naturally 3, 5, and 9. So now we know what is a diagonal of a matrix, and the last thing to do is now to have the sum of those values and return the absolute difference of the sum as mentioned here. So we make the first sum, we make the second sum, and we take the absolute difference and we return it. So that will represent that this is what we are supposed to do in this exercise. So now let us talk about the example. The example is just what we just described recently. We have to make a sum and we have to make absolute difference of the sum of the two diagonal. Now let us talk about the approach. How are we going to approach this? What is the implementation we are going to put in place to solve this problem? The first thing I'm gonna do is that I'm gonna go with the natural approach, which is I'm gonna take the matrix, I'm gonna read the value of the matrix, and from the value of the matrix, I'm gonna read the diagonal, and when I have the diagonal, I will return the absolute difference of those diagonals. But after that, I'm gonna share with you my thought about that and show you a better approach of doing this. So stay tuned to the end of the video and I'm sure you're gonna enjoy it. So let us move to the implementation of the code. Implementation of the code. We are going to start by removing all the dummy content we are not going to use to have a clean environment. We're not going to use this. We do need a main function, but we don't need this content. Cool. We don't need this one also. We need to return a 0 because it's an int main. So now what I was saying is that we need to have the matrix. To have the matrix, we are going to start by this is the input. This is what we have as input. So we need to have the size of the matrix. I'm gonna store it in this variable. So now I have the size of the matrix. Once I have the size of the matrix, I need to read the value of the matrix. And before reading the value of the matrix, I need to have the matrix being declared. So I'm gonna declare the matrix like this. It's a vector of int. This is something you should be familiar to if you are used to vector. This is actually a vector where each of the element is a vector. I'm gonna call it matrix, and the size will be n. But the initial value of the matrix should actually be a vector of int of size n. Sorry, so this syntax is showing me that I'm gonna create a vector of vector, and I will call it matrix, and the matrix will have n entry, which is the number of row, and each of the entry will actually be a vector of an element. So this will give me a matrix of, it will give me a structure, a data structure where we have n row and n column. So this is actually a matrix. Once you have the matrix, we can read now the values of the matrix. For this, we are going to use for loop. So let's go for row equal to 0, row lower than n, row. And for the other one, we are going to take, in call equal to 0, call lower than n, call. And from this, we are going to say, we're going to say matrix of row call. So this double for loop will help me to have all the values stored in the matrix. Now that I have the matrix, I need to compute the sum of the two diagonals of the matrix. Now the problem with that is, what makes a value part of a diagonal? Let us take the first diagonal. Yes, the first diagonal, right? We can see that this first diagonal represents the element in row 0, line 0. The second one represents the element in line 1, row 1. And the third one represents the element in line 2, row 2. So basically, all the elements of the first diagonal will respect the pattern of row equal to call. So we are just going to say, I need to repeat this. I need to have variable declare that will store, that will actually help me storing the different diagonal. I'll say diagonal left equal to 0. I will say diagonal right equal to 0. And from here, I don't need to read the value anymore. I just need to say if row equal to call. Then we say diagonal left, that's my first diagonal. We take now the value in that specific position, which is this. Now, once we have it, now what is the pattern of the second one? We can see that the first element here, I'll make use of this space to have something clear. This element is the element at position row 0, call 2. The second one is the element at position 1, 1. The third one is position 0, position 2, 0. So we are seeing that this second element is respecting a pattern when the row is increasing, the call is decreasing. And we can see that the sum of row plus call will always be equal to the size of the array minus 1, right? So from this, we can use this pattern to implement the second condition to have the dr sum. Okay, so I'm gonna remove this and I'm gonna copy paste this. So like we said, row plus call will be equal to n minus 1, and now dr will take the value. So at the output here, we'll be able to have the dl and the dr. So we can now see out the apps dl minus dr. The apps is actually a function that we apply the absolute. It will kind of compute the absolute value of a given integer. So what we are going to do is we are going to perform the difference dl minus dr, and we are going to make up this built-in C++ function to have the apps different. So let us run this and see what it gives. I hope you are clean. Okay, cool. We have the output 15. Everything is okay. Let us submit. We have a bunch of test cases, and let us see if we are okay. We are all green. Now, let us see our approach. Let us have a rough understanding of what we are doing. We can see that by reading those values, we have a lot of value that we are reading, we are storing here in the matrix that we are not using. For instance, when I'm reading all these matrices, I will never find myself using this to solve this problem. I will never find myself reading this to solve this problem. So my idea to optimize my algorithm will be try to get rid of all the elements I'm not using actually to solve my problem. So for me to solve this, the second approach I'm going to use is that I won't use a matrix anymore. What I will use is that I will directly read the value. I will read all the value, because to move from one value to another, you need to read all the values. So I'm going to read all the value. I'm going to store it in one integer. And whenever the value I'm about to read will respect one of those patterns, either this or this, I'm going to use it to add it to a given diagonal sum that I'm doing. So what will it look like? So I don't need this matrix anymore. Go away. I do need this one, yes, because I need to have the size of the matrix. I do need this one because I need to have this, I need to have this, and I need an input. I would say maybe item that will read each of the element. So you can put this and put it here to avoid having two int. Okay, you remove this. So when you are moving from row moving from 0 to n, and the column moving to 0 to n, the first thing you need to know is to read the element and read the item. So I have the item. Now I need to take, is the row equal to col? If yes, that means it's an item actually we need to use. So the item that has been read will be append to this element, the diagonal left. If the row and the col respect this pattern, then the given element will be append out to this. So yeah, we can see that we are able to have all the elements that we need to solve our problem without making use of the matrix, and it actually reduce the complexity of our program. So this approach, let us run and see what it gives before trying to saying is the best. We can see that we have a congratulations. Let us submit and see what it gives here. We can see that everything is green. So this approach is definitely better than the previous one in terms of complexity and in terms of cleanness of the code. You are taking only the value that you will need to solve the problem. So I hope you enjoyed the video. I would really enjoy having your feedback on this video. Feel free to comment, share, and stay tuned for the next video.